Hey guys, so today we're going to continue with our discussion of stoichiometry. So hopefully before you begin looking at this chapter, you reviewed the video from chapter 2 that dealt with converting from grams to moles and moles to grams. So I'm not going to review that here. If you didn't, go back and watch the video from chapter 2, because I'm going to assume you know how to do that. So last video we looked at mole ratios, what they are, how to find them. Today we're going to apply them to calculations. And really what stoichiometry calculations are is they're an extension of the grams to moles and moles to grams calculations. We already know the conversion factor to convert from grams to moles and moles to grams. That is our molar mass of our compound. In the last video, I gave you a new conversion factor that allowed you to convert from moles of one substance to moles of a different substance. So now we have a tool to convert from grams to moles, from moles of one substance to moles of a different substance, and then of that different substance we have a tool, the molar mass, to convert from moles to grams. So today what we're going to do is look at the 4 basic types of stoichiometry calculations, and I will give you an example of each. And then after the video, in the next couple of days, you will have some practice problems to get these basic calculations worked out, and then from there we will build on that and make them more complex. So if you look at the 4 pages in the next page in the notes is labeled 4 general types of calculations. So one thing that you'll always have to do is go ahead and write out the balanced equation, and it gives you a little hint up at the top. If you want to go ahead and write out the molar masses, that is great, a good thing to get in the habit of. But we won't always use all the molar masses, so I would suggest just waiting until you need a molar mass, then going and adding it up yourself. So let's go ahead and dive right in and look at number 1. Ammonia, NH3, is widely used as fertilizer and in many household cleaners. How many moles of ammonia are produced when 6 moles of hydrogen gas react with an excess of nitrogen? So let's first think about what that means. By doing that, we'll write out the balanced equation. We looked at it yesterday, so N2 gas plus H2 gas yields NH3. So I need to balance it with a 2 and a 3. We don't use that 6 to balance it because the 6 told us how much I have in my specific situation. So think about this as the reaction that's always true, and that number 6 just tells me in this certain situation how much hydrogen that I was given. So think about what an excess means. An excess just means I have enough of it. So I'm not worried about running out of nitrogen. I have plenty of it. It's an excess. But I am going to run out of hydrogen. So when you say you have an excess of something, that just means you won't run out of that one. You have plenty of it. So really what I'm trying to do is to convert from moles of hydrogen to moles of ammonia. So I want to go from moles of hydrogen to moles of ammonia. It might be helpful the first couple of times we do this to write that out, so you have a visualization of what you're trying to do. You're trying to convert from moles of hydrogen to moles of ammonia. So now let's think back to the beginning of the year. Think about dimensional analysis, how we start those off. This is just a basic conversion. If we have a conversion factor, we can do the conversion. So let's start off. We always write what we're given first. So I have 6 moles of H2, and it's H2 because it's diatomic. So I write what I'm given. And don't just write 6 moles. Write 6 moles of H2 because that's what I have. I don't just have moles, I have moles of H2. So these units on top, we drop down to the bottom. Moles of H2. So what I have goes on bottom, what I need goes on top. So moles of NH3 goes on top. I'm trying to find that. So now I have to ask myself, do I have a conversion factor to go from that converts between hydrogen and ammonia? So the answer is there a conversion factor that always works? Well, there's not necessarily one that applies to all situations, but from any given balanced reaction, you can create your own conversion factor, and that conversion factor is the mole ratio. So if we look how we have it set up here, it looks very similar to the mole ratios that we wrote yesterday. So let's produce the new mole ratio here. So in front of NH3, I have a 2. In front of H2, I have a 3. So that is my mole ratio. 2 moles of ammonia are produced from 3 moles of H2. So because I've built good skills and habits first semester, I know I need to go back and cancel my units. Moles of H2 cancels moles of H2. I'm left with moles of NH3. That's what I asked you for, so I'm in good shape there. So now I multiply across the top, divide by the bottom. So 6 times 2 is 12. Then I divide that by 3, and I get 4. So my answer is 4 moles of NH3. Okay, so now I can say by reacting 6 moles of hydrogen, I can produce 4 moles of ammonia. So as you probably realize, that by itself is not a super helpful calculation because I can't go out and grab 4 moles of hydrogen. I can, however, using mass, measure out a certain amount of a compound. So what we want to do is expand this calculation further and look at how to find amounts in grams, to find masses in grams by using this. So the next type of calculation, after we did a mole to mole calculation, is a mole to gram calculation. So let's read the question. When magnesium burns in air, it combines with oxygen to form magnesium oxide. According to the equation below, what mass in grams of magnesium oxide is produced from 2 moles of magnesium? So the first step, balanced equation. So Mg plus O2 yields MgO. Magnesium's plus 2, oxygen's minus 2. I'm in good shape there. I put a 2 there and 2 there, and I have a balanced reaction. So now I can do my calculations here. So I want to go from moles of magnesium all the way to grams of magnesium oxide. Do I have a conversion factor that converts from grams of magnesium oxide, moles of magnesium to grams of magnesium oxide? The answer is no. I do not have a single conversion factor. So let's think about what I can do. So I want to ultimately end up with grams of MgO. But I don't have a conversion factor that goes straight from here to here. So let's think about what I can do with magnesium oxide. What number could I convert to grams of magnesium oxide? Well, if I had moles of magnesium oxide, then I could convert that to grams of magnesium oxide using the molar mass. Okay, so that's a step in the right direction. But then, can I convert from moles of magnesium to moles of magnesium oxide? Well, now, yes, I can, because I know that I can use mole ratios to convert from moles of one substance to moles of another substance. So now let's set up the calculation. I have 2.00 moles of magnesium. Okay, the units that I start with, I want to get rid of, drop down to the bottom. So I have moles of magnesium. Next, I'm trying to convert to moles of magnesium oxide. I need a conversion factor. That is a mole ratio. So I put a 2 right there, and I put a 2 right there. So in this case, those are going to cancel out, but we still want to write them in because they won't always cancel. So then I keep going. I'm not done. Now I drop moles of magnesium oxide. And I ultimately want to find grams of magnesium oxide. So now, do I have a conversion factor to go from moles to grams? Yes, I do. I can use the molar mass of magnesium oxide. So there are 40.31 grams in 1 mole. So pause the video, make sure that you can add up the molar mass of magnesium oxide and get 40.31. So now, I think I'm done, but before I do the math, I want to check my units, make sure the units cancel. So I have moles of magnesium, moles of magnesium, moles MgO, moles MgO. I'm left with grams of MgO, which is what I ultimately asked for, so I'm in good shape there. So now I do the math, multiply across the top, divide by 2 on the bottom, or you can go ahead and cancel the 2's out, it really doesn't matter. Whatever you do though, you should get 80.6 grams of MgO. I round to 80.6 because I have 3 significant digits up here. So you cannot write 80.6 grams and be correct. It's 80.6 grams of MgO. You have to tell me what you have 80.6 grams of. Okay? So that still involves starting off with moles. So we're not quite where we want to be yet, but we're heading in the right direction of producing some very useful calculations to us. So now let's look at reaction type number 3, converting from grams to moles. So it gives you a little scenario there. You can read through it. Ultimately, what we want to do is write a balanced reaction there. So I have 2 HgO produce 2 Hg plus O2. So I begin with 125 grams of oxygen. So I'll write up here grams of oxygen. And ultimately, I want to convert to moles of HgO. Do I have a conversion factor that takes me straight from grams of oxygen to moles of HgO? No, I do not. But what can I convert grams of oxygen to? I can convert grams of oxygen to moles of oxygen by using the molar mass. So now ask yourself, can you convert from moles of oxygen to moles of mercury oxide? Yes, you can, using the mole ratio. So there is my little roadmap for how I'm going to convert from grams to moles. So let's go ahead and set up the dimensional analysis problem. So I have 125 grams of O2. I like to go ahead and draw the whole thing out. So then I drop the units I want to get rid of down to the bottom. I have grams of O2. I convert that to moles of O2. My conversion factor from grams to moles is the molar mass. Because it's O2, I have 16 plus 16, so I have 32.00 grams of O2 is 1 mole. So then I drop down moles of O2. And I want to convert from moles of O2 to moles of HgO. My conversion factor here is my mole ratio. I go to my formula and I find it. So I find that 2 HgOs produce 1 O2. Because I'm a good student, I go back and check my units. Grams of O2, grams of O2, moles of O2, moles of O2. You're left with moles of HgO, which is what I asked you for, so we're in pretty good shape now. So I go through, I do the math, I multiply across the top, divide by 32, and I get 7.81 moles of HgO. I have 3 significant digits here, so I round my answer to 3 significant digits. Okay, so again, that's a good calculation, but again, it's not what we're ultimately trying to do because we still have moles involved. What we're ultimately trying to do with stoichiometry is to convert from grams of one substance to grams of a different substance. So let's go ahead and combine all 3 of these calculations we've done so far to do the 4th type of stoichiometry calculation. And this is by far the most common type of stoichiometry calculation, converting from grams of one substance to grams of a different substance. So you can read through the little paragraph there. It tells you about laughing gas. So you can write out the balanced equation. You have ammonium nitrate, NH4, NO3, produces N2O plus 2 H2O. So let's go ahead and look at our plan for what to do. You're given an amount of water, amount in grams. You're asking how many grams of ammonium nitrate are required to produce that. So ultimately what I'm trying to do is I'm trying to convert from grams of water all the way to grams of ammonium nitrate. Do I have a conversion factor for that? No, I do not. I cannot convert from grams of one substance to grams of a different substance. So what I need to do is to first convert from grams to moles. I can convert from grams of water to moles of water. Okay, now can I convert from moles of water to moles of ammonium nitrate? No, I cannot. But I can use my mole ratio to convert from moles of water to moles of ammonium nitrate. And then I can convert from moles of ammonium nitrate to grams of ammonium nitrate. So let's go and set this calculation up. So you start off with 33.0 grams of H2O. So I'll go ahead and draw the line all the way across. I drop these units down here, grams H2O. I want to go from grams of H2O to moles of H2O. Sorry, I left my L off there. So I plug in my conversion factor to go from grams to moles. My conversion factor is 18.02 grams is in 1 mole. Now I drop moles of H2O down. Moles H2O. I want to convert that to moles of ammonium nitrate. Okay. So I look at my balanced equation. I see I have 2 in front of water and 1 in front of ammonium nitrate. That is my mole ratio. And then finally, I drop these units down. My line was almost long enough. Moles NH4, NO3 to grams of NH4, NO3. So I look up my molar, or I add up my molar mass for ammonium nitrate, and I see that it is 80.06 grams in 1 mole. So I go back and check my units: grams of water, moles of water, moles of water, moles of ammonium nitrate, moles of ammonium nitrate. I'm left with grams of ammonium nitrate, which is what I asked you for. So we're on the right track. Plug in the calculator, multiply across the top, divide by the bottom, and you get 73.3 grams of NH4 NO3. I have 3 significant digits here, 3 significant digits here, so I'm in good shape. This is what we're ultimately trying to do. We're trying to convert from grams of one substance to grams of a different substance. So notice in this question, it was kind of backwards. It gave you grams of product and asked you to find grams of reactant. That doesn't change the problem any. Think about it as just one big conversion problem. You're trying to convert from grams of one substance to grams of a different substance. If we had said how many grams of water can be produced from 15 grams of ammonium nitrate, it'll be the same process. Grams of ammonium nitrate to moles of ammonium nitrate. Moles of ammonium nitrate to moles of water. And you go on and do the calculation. So we can pretty straightforward do any calculation here by just doing conversions step by step. So we can look at more problems in the coming videos, but for now we'll stop, and this is the most complex problem we'll look at today, but this is also the most common type of calculation. We'll do other calculations in select circumstances where you start grams, end up in moles, but the majority of the time, we'll start with grams and want to end with grams. Okay? So don't get too bogged down in what the question's asking you. Focus, obviously pay attention to what it's asking you, but don't stress out about how to do it. Try to distill the question down and simplify it. Think about, can I convert from grams of this substance to grams of a different substance? And likely the answer is yes. One thing to keep in mind is, you might want to make a note of this, the only way, and I'll write this down, the only way to convert from one substance to a different one is by using the mole ratio. So let's just look at a few examples. Let's just say I have grams of A and I want to go to grams of B. Can I do that? Well, if I have a balanced equation, yes. We'll assume there's a balanced equation out there somewhere. Let's look at the steps that are necessary to do that. I need to go from grams of A to moles of A. From moles of A to moles of B. Then from moles of B back to grams of B. So then for these conversion factors, this one would be the molar mass of A. This one would be the mole ratio. This one would be the molar mass of B. So we can do that, but all these calculations that require going from an amount of one substance to amount of a different substance require the mole ratio. So even if I ask you to go from grams of A to moles of B, I still have to use the mole ratio. I cannot go straight from grams to moles. The mole ratio only goes from moles of one substance to moles of a different substance. So here I would have to go to moles of A then to moles of B. Here I would use the mole ratio, and here I would use the molar mass. Okay? So hopefully that clears things up, and you will be confident moving forward in these calculations. Again, we'll do some of the more simple ones, but moving forward we'll focus on the more complex ones, moving from grams to grams. Just don't forget, look at it step by step. Think about what conversion factor you need to do the transformation. If you're converting from grams to moles or moles to grams, you need molar mass. If you're converting from moles of one substance to moles of a different substance, you need the mole ratio. And if you're trying to go from grams of one thing to grams of a different thing, or grams of one thing to moles of a different thing, break it down into a multi-step process. A lot of these calculations cannot be done in one step. But if you do it step by step and break it down, you can think about what conversion factors are necessary to do each transformation.